Have you ever stopped to think about how a massive organization, I'm talking a huge university or a sprawling multinational hospital, actually makes sure you can only see the files you're explicitly supposed to see? Think about it for a second. With thousands of employees, students, and constantly shifting departments, how on earth does the system know exactly who gets access to the sensitive payroll data and who gets completely locked out? Honestly, it's a massive, agonizing headache for IT departments everywhere.
Well, today we're exploring a seriously brilliant machine learning solution to this exact headache. In this explainer, we're unpacking a fascinating research paper that details a system called PAMMELA. We're going to look at how machine learning is just completely transforming how organizations handle their internal security and data privacy.
Okay, let's dive into this. Here's our roadmap. We'll start with the access control evolution, look at the policy update headache, and then enter PAMMELA. After that, we'll cover how PAMMELA learns, how they're boosting the brain power, and finally, get to the final verdict.
All right, Section 1, the access control evolution. To really appreciate the solution, we kind of need to understand the problem first, right? Back in the early days, systems used really rigid models like discretionary or mandatory access control.
So, for a long time, the gold standard was role-based access control, or RBAC. Basically, you're assigned a role, say manager, and boom, you get all the permissions of a manager. Super simple, right? Well, yeah, until it completely fails in dynamic, collaborative environments. I mean, if two different companies try to collaborate, their definitions of manager might be completely different. So, the industry shifted to the new way, attribute-based access control, or ABAC. Think of ABAC like a highly specific, incredibly strict bouncer at the door of your data. This bouncer doesn't just glance at your job title, no, they check your department, your specific designation, the exact type of resource you're trying to access, maybe even the time of day. It's incredibly secure and super flexible.
But, as you can probably guess, that strict security comes at a hefty cost. Section 2, the policy update headache. Because ABAC is so incredibly specific, it absolutely relies on a massive database of meticulously crafted rules. And organizations, they're living, breathing things. What happens when a hospital starts treating patients in a brand new specialization, or a university opens up a new department or introduces a new degree program? Every single one of these real-world changes is a trigger. It literally forces IT admins to sit down and manually rewrite or slowly add complex security rules, usually while, a dozen people are waiting on hold complaining they can't log in. It's just an agonizingly tedious chore.
So the crucial point here, and the researchers hit the nail on the head, is that designing an ABAC policy, ab initio, demands a substantial amount of effort. And ab initio, by the way, just means doing it entirely from scratch. Remining these policies from zero, or manually hunting through endless databases to update them, it wastes massive amounts of time and is highly prone to human error.
Which brings us to the hero of our story. Section 3, enter PAMMELA, machine learning to the rescue.
PAMMELA stands for Policy Administration Methodology Using Machine Learning. Now, I want you to picture PAMMELA as this hyper-efficient, incredibly observant virtual assistant. PAMMELA doesn't actually need to be explicitly told every single new rule from scratch. Instead, it learns the ropes simply by watching what the organization already does. It's a fully automated strategy that infers new access rules based entirely on the existing ones. How cool is that?
And it can even do this across different organizations. The researchers call this adaptive policy inference. So let's say XYZ University has this perfectly functioning ABAC system. Now, PQR Institute, which has a pretty similar structure, wants to set up their own security. Instead of starting from absolute zero, PAMMELA can take XYZ University's existing reference policy and instantly adapt it to build a target policy for PQR Institute. It just handles all those little dissimilarities automatically. But how does it actually pull this off? Let's look under the hood. Section 4, how PAMMELA learns.
The mechanics basically work in two distinct phases. Phase 1 is all about training. The machine learning classifier gets fed the existing ABAC policy, and it learns the positive rules, the exact conditions where access is granted. But, and this is absolutely vital, it also learns the negative rules. It has to know exactly when to deny access. Because in the real world, the list of things you aren't allowed to do is usually way longer than what you are allowed to do. Once it's trained up, it hits phase 2, testing. The classifier gets hit with new access requests featuring new attributes, like, say, a newly created department. It processes this and simply spits out a yes with the required permissions or a hard no to deny access.
And this brilliantly illustrates the whole process. Following the workflow from start to finish, we kick off with the existing policy database. That gets fed right into phase 1 for training.
Then, over in Phase 2, those new access requests and attribute information get introduced. PAMMELA tests them out, generates the brand new ABAC rules, and finally drops them right into the updated policy database. The whole shebang is automated. Literally zero human intervention required.
Now, the researchers didn't just stop at a basic model. Section 5, boosting the brain power. They actually threw in two really clever enhancement techniques to make this AI even smarter. These two techniques are ARFE at AVC. Let's break those down. ARFE stands for Attribute Relation-Based Feature Extraction. Basically, this teaches the AI to look for relationships. For example, if a student is registered for a database systems course, well, they should probably have access to the database systems assignment, right? The attribute course links the person to the file. ARFE captures that exact relationship, which is a total game changer. Then you have AVC, or Attribute Value Clustering. This groups functionally similar items together. So if the AI knows how to handle a quiz and an assignment, AVC helps it realize that, hey, a question paper and an answer script are pretty similar types of resources, so they should probably share the same access structures.
All right, so does all this theoretical brain power actually hold up in practice? Let's get to Section 6, the final verdict. It is time to look at the hard data. To test this, the researchers carefully crafted 3 manual datasets to mimic real-world organizations: University Dataset 1, University Dataset 2, and a company dataset. They ran these through multiple machine learning classifiers like decision trees, random forests, and gradient boosting. But I really want to focus on University Dataset 2. This dataset is absolutely massive. It contains an unbelievable 156,775 training rules. I mean, that is a true test of scale for PAMMELA.
And honestly, the results were phenomenal. When they used the gradient boosting classifier on that massive University Dataset 2, just using a basic naive approach wasn't quite enough. But when they combined ARFE and AVC together, giving the AI that ability to spot relationships and cluster similar items, they saw a staggering 95.4% F1 score performance jump over the naive approach. And if you're wondering what an F1 score is, it's just a metric that perfectly balances precision and recall. Basically, it means the system wasn't just blindly letting everyone in, but it also wasn't being overly restrictive and locking people out by mistake. It was just highly accurate and incredibly secure.
So the data clearly proves that PAMMELA works. It heavily reduces administrative overhead and basically eliminates manual errors. But it leaves us with a really fascinating thought about the future, one that comes straight from the researchers' own conclusions. Think about it. If PAMMELA can effectively adapt policies from one organization to another, can machine learning soon manage and resolve security conflicts across multiple collaborating organizations at the exact same time? Just imagine an AI seamlessly negotiating data privacy between a massive global hospital network and an external research university, all in real time. Truly, that is where this technology is heading next, and I cannot wait to see it.